Okay, good afternoon. So we shall continue the class. So I'm trying to revise you. I'm trying to revise you on complexity analysis of divide and conquer application or divide and conquer strategy. Okay, divide and conquer DAC is one of the strategies, one of the good strategies to solve the problems. So for this, I'd like to take an opportunity to revise how to evaluate the complexities here. So as far as the divide and conquer is concerned, we have a master theorem or a recurrence relation, which is useful to us to evaluate the divide and conquer by using divide and conquer technique. That master theorem, otherwise the recurrence relation, will be T of n equal to T of n will be equal to T of a into T of n by b plus f of n. This is the master theorem, which is being derived by Sir John von Neumann in 1952. Based on this particular master theorem, the divide and conquer and many other techniques, not exactly divide and conquer, many other techniques also be there. Those techniques also be evaluated by using this kind of master theorem here. So here, values of a, b, and f of n will be differed, or will be having different kinds of values for one problem to another problem. Let me discuss with one by one each. Then we'd like to solve at least two evaluations for today. Okay, very important evaluation is quicksort and medgesort average case complexity is very important. That could be there in our final examinations also. That's very important for you. So here, if you consider the binary search technique, so binary search technique is a binary search will be okay. Morning, I got very good writing today. Now it is not that much good. However, so here a will be equal to 1. Why it could be taken a will be equal to 1? Let me explain for time being. And b will be, so divide and conquer is always specifies that. So you have to divide the list of elements or list of records or list of values, whatever it may be, by exactly 2. That is the standard notation of divide and conquer. So it must be taken 2. And for binary search, number of comparisons will be 3 for each and every recursive call. So therefore, f of n will be equal to, actually we have to write 3. We have to write 3, but of course, so it is not feasible to write 3 in a generic mode or general mode, so that it could be written as C. C will be constant number of comparisons will be happen when binary search is being done here. What are those constant number of operations will be? Number 1, f mid equal to required element or not. If it is not, so element is greater than f mid. If it is not, element is less than f mid. So totally 3 different operations are being done over there. Okay, so that is fine. This one. So based on this particular thing, the master theorem will be taken into like this for binary search. The binary search operation. The master theorem can be seen. So T of n will be equal to T of n will be equal to, so T of n by 2, T of n by 2 plus f of n value is C. So this is the master theorem substituted values of binary search. This is exclusively for binary search. Okay, this would be the exclusive for binary search. Whereas, if you go ahead, what does it mean? Why a will be equal to 1? Why a will be equal to 1? So let us consider, if we take some list of elements, something like this. So we have to identify a mid element here. A mid element here, this is the mid element. And within this particular mid, we have to search for whether this particular element, let me consider that is X, and I want to search for ELE. I want to search for one particular element that is ELE. Whether A of mid, this list will be considered as A, for example. Whether ELE equal to A of mid or not. If that is failed, obviously we'll go ahead with element is greater than mid or element is less than mid. Something like that we have said. So certainly we could consider either of these sublists, either this particular sublist or this particular sublist will be taken into consideration for binary search. For example, element is less than mid in the sense this particular sublist will be eliminated from our search space. Previously, in the beginning, search space will be n elements. After first recursive call, search space will be n by 2 minus 1. After second search recursive call, n minus 4 minus 1, and so on and so forth. It could be happen. So this will be eliminated from our search space. So we are not supposed to consider to search anything within this one, provided element is less than mid, A of mid. So that is why A equal to 1. That is the basic reason why A equal to 1 has been taken. Based on the mid element, so list will be divided into 2. So that is why B equal to 2. Number of comparisons will be 3. So we are not supposed to write 3 over there, so that we'd like to write number of comparisons. Constant number of comparisons will be done, so that is C. That is why we would like to write such a way. And followed by, so quicksort. Quicksort could be having two different types of complexities, that is average case and worst case. Worst case could be scenes, so that is order of n square, whereas average case will be n log n. Whether it is quicksort or merge sort, so if you consider this one, the values which are being available with the master theorem, that is A, B, and f of n, will be taken something like this. So while we are taking, so however, whatever the sort it might be, so we have to consider, we have to take in both sublists to be taken into consideration for sorting. If you sort only one sublist and left over with second one, so the sort could not be completed. So therefore, value A will be equal to 2. Two sublists are supposed to be taken into consideration for every recursive call. And how many number of so how can you divide the sublist in the sense? So based on the B will be always equal to 2 as far as the divide and conquer technique is concerned here. And f of n will be always taken into consideration that number of swap operations will be 2. That is a constant number of swap operations will be done. And the number of comparisons will be n number of comparisons will be done for every recursive call. If in the beginning of the story, number of elements will be n, so that n number of comparisons will be happen. After identifying the pivotal element in quicksort, or after division will be happen in midsort. So while sorting is being done, then so n by 2, n by 4, n by 8, and so on and so forth. N will be take its own values for the each and every recursive call. On substitution of these values, how the value could be, how the things will be here in the sense, T of n will be equal to, T of n will be equal to 2 into T of n by 2 into T of n by 2. Wait, the power has gone. Yeah, the power has gone. I think everybody are there in the line. So everybody is there in the line. Okay, however, I'm trying to connect with my mobile phone. Yes, it has been connected. However, so T of n by 2, so plus, so f of n value will be equal to C into n. So this is the average or so any kind of complexity for sorting kind of applications in divide and conquer application. So these are for sorting kind of applications. Okay. So one moment, please. So these are the sorting average case or worst case which is being taken into consideration by divide and conquer. And one more algorithm is there. That algorithm is min-max. So if you consider MIN, so MAX kind of algorithm, so max-min or min-max algorithm. So if you take into consideration, it could be taken. So number of elements will be n. So therefore, it could be taken T of n will be equal to. So both sublists are going to be taken into consideration. So T of 2 into T of 2 into T of n by n by 2 plus, so how many number of comparisons for every, so recursive call will be happen here in the sense, the number of comparisons will be two comparisons for minimum of comparison and maximum another comparison, so that it could be considered as. So you may be asked one question at this point. So here we have done some kind of uh, 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 constant number of comparisons here, swap operations for this one here, why you have to place C and why you have to place so only 2 here, this particular value, why you have to place here in the sense. So for min-max kind of element, if you want to perform so greater than or less than kind of operation, for example, if you could take greater than, it must be required some 2 different types of parameters or operands are required here. So these 2 operands will be always so taken into consideration for comparing each other. Okay, then for minimum 1 comparison, for maximum another comparison. 2 comparisons will be took place, and these 2 are the constant comparisons. Okay, every time these 2 could be done. But here, so in sorting or searching in these 2, we are not sure that the swap operations will be continuously gets operated or not. We are not sure. So here, A of mid will be equal to given element, then search will be gets completed. Remaining 2 different operations could not be, different comparisons could not be took place. So we are not sure that all these 3 comparisons will be took place here. We are not sure that all 2 swap operations are there. So those 2 swap operations will be done properly or not. We are not sure. So that is why we have to take here C and here also C. They are uncertain. But here it is certain. Yes, every time for minimum 1 comparison, for maximum another comparison. 2 comparisons must be done. Okay, so that is why here we have placed 2. That is the reason behind this, why we have to place 2 here. So we have to evaluate these 2, these 3. So at least so 2 will be gets evaluated. Of course, defective chessboard problem also there with us, but that is not asked you in your final examination because unable to draw many number of squares or many number of chessboards by using any paper and pencil method. So that is why that could not be asked to you in your final examination. However, let us evaluate this one first. So out of all these, you need to remember divide and conquer will be always taken one some primitive. That primitive is n will be equal to 2 power k. After recursive calls, total number of elements which are required for so divide and conquer basic approach will be taken. That is, basic approach will be always taken. So small of p will be get satisfied after k number of recursive calls if you operate them in 2 power k. Okay. So otherwise, this could also be taken. So this could also be written as something like this: n divided by 2 power k will be equal to 1. Okay. So that is 1. So you need to remember this is the basic primitive of so divide and conquer. It must be also there in our mind forever. Okay. Now let me copy this particular thing here. So binary search, for binary search, how this could be gets operated. Let us do. So T of n will be equal to T of n by n by 2 plus c. This is the equation number 1. Equation number 1. And we need to identify what is the value of T of n by 2. So T of n by 2 will be equal to T of n by 2 value equal to T of n by 4 plus c. This is equation number equation number 2. Okay. Then T of n by 4 value also gets identified here. T of n by 4 so will be equal to, if anybody are not having, not attended during those classes, yes, you can write them. Use paper and pen, you have to write them. So T of n by 8, so n by 8, so plus c. So this is equation number 3. Okay. Substitute equation number 2 and 3 in equation number 1. Okay. So therefore equation number 1 can be becomes something like this. So something like this. T of n will be equal to, T of n will be equal to, so T of n by 2 value is T of n by 4, T of n by 4, so plus c, so plus c, that is T of n by 4 plus 2c, that equal to T of n by 4, so n divided by 4, so plus 2c. Okay. Then substitute the value of T of n by 4 here. So that is T of so n by 8. After substitution of this T of n by 8, the value will be plus 3c. After complete substitution of a thing, it could become 3c. And continue. So you can change the values where exactly possible to convert into 2 power 3s. So therefore, it could be seen, so T of n divided by 2 cube plus 3c plus 3c. Okay. So then that could be, so not that could be this, continue this process for k recursive calls. K recursive calls. For k recursive calls, you have to continue this particular process. Then T of n will becomes, T of n will becomes, so T of n divided by, so 2 power k, so plus kc, plus kc. This is the way it could be done. So this will be equation number, okay, next equation, that is the 4th equation. As far as previous discussion, of course, one more case has been taken into consideration in the previous discussion. So that is why it has been 5th equation during that discussion. However, there is no problem at all. After this, the basic primitive of divide and conquer will be n will be equal to 2 power k. 2 power k. Apply log base 2 on both sides. Log base 2 on both sides. If you apply this log base 2 on both sides, so it could be becomes something like this. Log base 2 n will be equal to, so log base 2, so 2 power k. 2 power k. Then it could be becomes log base 2, so n will be equal to, so k into log base 2 k into log base 2. Therefore, the value of k will be becomes, so because log base 2 equal to 1, log base 2 equal to 1, so therefore k value will be becomes, so log base 2, let me say, yeah. So let us consider this is equation small 1 and this is equation small 2. Okay, small 2. These two will be substituted in this equation. That is T of n equal to T of n by 2 power k plus kc. So substitute these two in this particular equation. So therefore, it could be seems, so T of so n will be equal to T of n divided by 2 power k, so plus kc. This is the actual equation. So instead of 2 power k, you have to substitute as n. Instead of k, log base to n will be substituted. So that equal to T of n by n, so plus log base to n into c. Okay. T of n by 1, n in the sense T of 1 equal to 1. So therefore 1 plus the log base to n into C. So I'd like to write C here, C into log base to n. When compared to log base to C into log base to n, so this 1 is very negligible value, so that we have to eliminate that one. So you could get the C into log base to n will be the value. C is a constant, so eliminate this particular constant also from this equation, so that you could get T of n will be equal to so log base to n, which is also considered as big O of log base to n. So this is the way you have to evaluate. This is the way you have to evaluate by using this one here. I would like to scroll down very slowly. You please observe. I'd like to scroll down very slowly. You please observe. Okay. You please observe what other things are being happening here. I'd like to scroll very slowly. Okay, very slowly. I'd like to scroll. You can go ahead and, of course, I'm writing everything by using mouse, so that sometimes things will not be in a proper way. Using mouse, everything has been written. Please go ahead. Try to go through the particular thing, what is actually happening. Try to understand. Okay. Then if things will be get over, then I'll move to one more. Okay. Now let me go ahead and take the explanation for quicksand. Explanation for quicksand. Now let us see. Quicksand is being taken. Quicksand or mudslide, whatever it may be, being taken something like this. So case one. Case one. So that is if n will be equal to exactly one element, n will be equal to exactly one element, then we'd like to consider, so it is already in sorted order. One element in the sense it is already in sorted order. So therefore T of 1 will be considered as 1. Let me consider this is the equation number 1. This is equation number 1 in terms of this one. Okay. Then so after taking that is equation number 1, then we'll go ahead with case 2. Case 2. Case 2 will be, so case 2 could be considered as T of n equal to, already we have substituted some values in the previous time. T of n will be equal to 2 into T of, so n by 2. Oh, one more time, the power has gone. Sorry for this. The power has gone. So T of n by 2 plus, so C into n. This could be equation number 2. And get the value of T of n by 2. So therefore, at least three equations could be drawn by you here. So T of n by 2 will be equal to, so 2 into, so T of n by 4, so n by 4 plus C into n. Let us consider this is equation number 3. Okay. Then, so T of n by T of n by 4 value also gets identified by you. That could be equal to 2 into, so T of n by 8 plus Cl. Let us consider this is equation number 4. That is equation number 4. Okay. Now, what we are trying to do here is, so you have to substitute equation number 3 and equation number 4 into, so into equation number 2. Okay, you have to substitute it. After getting substitution, what you are supposed to get? So you could get this particular kind of thing here. This is the specification you could get here. That is the T of so n will be equal to, T of n will be equal to 2 into, so T of n by 2 value is 2 into T of so n by 4 plus Cn. I'm sorry, here I wrote something wrong here. C of n by 2 here it is. Sorry, n by 2. That is n by 2. I'm sorry to inform you. So here T of n by 2 will be there. This is T of n by 4 will be there. N by 4, because n by 4 in the sense n by 4 number of times comparisons will be happen. N by 2 in the sense n by 2 number of comparisons will be gets happen over there. Okay. Then C of n by 2 plus Cn. Then that could be equal to 2 into 2 square. Otherwise 4 you can write anything. Otherwise 2 square, or otherwise so 2 power 4 actually you could write. So T of so n by 4 plus, so this 2 and this 2 will be gets cancelled. So therefore Cn plus Cn 2 into Cn. Then substitute the value of T of n by 4. That could be equal to, so 2 square into, so 2 square into T of n by 2 into T of n by 2 into T of n by 4 n by 4 plus Cn by 4, so plus Cn. Okay. Then evaluate this one, elaborate this one here. 2 square into 2, that is 2 power, so 3 into T of, it is T of n by 8. Sorry, this is T of n by 8. I have substituted wrongly. So T of n by 8, so plus this 4 and 2 square will be gets cancelled. Cn plus, so here it is 2 Cn. So Cn plus 2 Cn, that is 3 Cn. And convert where exactly possible to convert into 2 power 3 to 2 powers, then convert everything here. So already it is 2 cube. It is already in 2 cube only. T into n divided by, so here also you could able to write 2 cube. So plus 3 Cn, 3 into C into n, 3 Cn. And this procedure will continue for k iterations or k recursive calls. So then T of n will become something like this. After k recursive calls, then it could be converted into, so 2 power k, okay, 2 power, so k into T of so n divided by 2 power k plus kcn, a into c into n. Let us consider this is equation number 5. Okay, equation number 5. Then the basic primitive of divide and conquer will be, basic primitive will be always taken. So n will be equal to, so 2 power k, this is the basic primitive. Equation number small 1. Apply log base 2 on both sides. Log base 2 on both sides. So therefore log base to n, log base to n will be equal to, so log base 2 power k. Of course, directly I'd like to write, therefore k will be equal to, log base to n. This is equation number, so 2, small 2. Substitute these two in the equation number 5. Okay, so look at the equation number 5 here. This is the equation number 5. Substitute the values to the equation number 5. Therefore, T of n will be, equal to, so 2 power k, in the presence of 2 power k, you can substitute this one. In the presence of k, only k, you can substitute this one here. Here 2 power k will be there here. So therefore 2 power k in the sense that is n. So T of n by 2 power k, again 2 power k will be there here. So therefore it could be substitute of T of n by, so n plus, so here it is, we have k, instead of k, second equation could be get substituted, that is log log base 2, so n into cn. Okay, substituted in such a way. Then elaborate it. T of n by n equal to 1. T of n by n equal to 1. Since it is 1, so that could be equal to n plus, so cn into log base to n. Cn into log base to n. Now, when compared to this particular term, this value n is negligible, so that it could be eliminated. So n is very, very lesser value, so it could be eliminated, and then you could get to c into n. So log base to n. So constants are not supposed to be taken in approximations. Otherwise, in terms of asymptotic notations, so constants are not supposed to be considered. So that you have to eliminate them. Then you could get so T of n will be equal to, so n log base to n. Therefore, it could also called as big O of n log base to n. Why I have taken this particular class today? Actually, I must move to greedy method. Directly, we'll go to greedy method. So, but here the things will be very, very important here. So, this evaluation is very important, and we have to write in our final examinations. Without writing all this particular evaluation, you could not get the marks. Please remember. I'll send this particular evaluation to your this particular paintbrush picture image will be sent to your group. You please open it and you have to go through it. Okay. So in this way we can evaluate it. Okay. I'll send you. So open and go through it one more time. If any questions, please drop your mail or drop your post to Google Classroom. I did not receive any question from you people. Thinking that you do understand everything or you do not understand everything, I could not get the point. So somehow, in this way, you could get the things here. Okay. So this is what the class for today. And tomorrow we shall move to next unit. That unit is that's also very important unit for you. That is the greedy method. Okay, the greedy method. Tomorrow we shall move. Thank you. Just wait for a while. I'm taking attendance of you. Please don't go away. I'm taking attendance of you. Okay. Yes, one thing is gets over. Only 32 students have been attended here. Okay. Attendance has taken. Immediately I have to forward the document to you. So please go